So in this video we're going to find the radius of convergence of this power series here. We've got the summation from n equals 1 to infinity of n to the power of n times x to the n over n factorial. So a lot of n's and this one term here x to the n. So when finding the radius of convergence of a power series, first thing I look at is to find my nth coefficient. So the nth coefficient is calculated by removing this summation term and taking out any x to the n. So we're just left now with n to the n divided by n factorial. So that's our nth coefficient. Okay. Now, with a power series and an nth coefficient looking like this, the method I would recommend is the ratio test. So the ratio test, as the name suggests, involves some sort of division. So the ratio test is found by taking the limit as n approaches infinity of the absolute value of the n plus 1th coefficient, so a subscript n plus 1, and then divide that by the nth coefficient, and then close the absolute value, and this will give us a result which I'm going to call R. You can call it any name you like. Some people call it L, some people call it K, some people call it C. It doesn't really matter. What matters is that this here will give us a value which will be a positive number or 0, and from that what will happen is we can then determine what the radius of convergence is by using that. So first of all, we've got our a to the n, which is this term here. Now we need our a to the n plus 1, our n plus 1th coefficient. So let's find out what that is. So what we do is we take our nth coefficient, and wherever we see an n, we plug in an n plus 1 in its place. So n plus 1, we'll put that in the first place, and then to the power of n plus 1. And then divide that by n plus 1 factorial, remembering to use brackets, especially for this denominator term. Okay, now in previous videos, if you check on the link below, we've always broke this down into more simpler looking algebra before we plug it into our ratio test. So this here can be rewritten as n plus 1 to the n. So that would take care of this bit here, and then with this plus 1, we just multiply that by another n plus 1. And then our denominator, n plus 1 factorial, well, that is just simply n plus 1 times n factorial, by nature of what factorial is. So already, before we go into this, we've got some simplification using algebra for our n plus 1th coefficient. So these n plus 1s will cancel each other out. So that's making this step even easier for us. So let's plug this in now and see where we go. So R equals the limit as n approaches infinity of n plus 1th coefficient, which is this one here. So we've got n plus 1 to the n, and then divide that by n factorial. So that takes care of that. Okay, so now we need to divide it by the an, the nth coefficient. So now divide that by n to the n and n factorial. And as that's in our denominator, we can just flip it over and take the reciprocal. So the n factorial I'm going to put in the numerator, and the n to the n I'm going to put in my denominator, and then close that off. Okay, now that's factorial. Okay, so n factorial, they can both cancel off. And now we're left with n plus 1 to the n divided by n to the n. Now, as n approaches infinity and n is always positive, we can now lose the absolute value as well on the next level of working. So the limit as n approaches infinity is n plus 1 to the n divided by n to the n. Okay, now both terms in the top and bottom are to the power of n. So we can rewrite that as the limit as n approaches infinity Now, n plus 1 divided by n, all to the power of n. So that is now the same term. Now we can break this down now into dividing the top and bottom by the top by n on both terms. So now we've got the limit as n approaches infinity of n over n is 1, and then 1 over n. So we add 1 over n, and that's all raised to the power of n. Now this here is a very famous, as n approaches infinity, this just gives me e. So therefore in this case, my r equals e. So if I just put my re here, r equals this limit, and this equals e. Now 1 plus 1 over n to the n, as it's e, and this is our r, we can just take the reciprocal of that, and then that will give us our radius of convergence. So our radius of convergence is just basically 1 over e, or you can write it as e to the minus 1 if you preferred. So that is the result of the radius of convergence of this power series. So therefore, the largest disk for which this series converges is 1 over e. Okay. There we go.